So given the points negative 8, 6, and 6, 9, find the slope. So the slope is rise over run. So in our case, we want to look at the difference of the y values divided by the difference of the x values. We just need to make sure that we take the same. We have to be consistent in how we choose the x's and y's here. So if I start with 6 and 9, for example, then the y-coordinate of that point is 9, and the x-coordinate of that point is 6. And then the y-coordinate of the second point is 6, and the x-coordinate of the second point is negative 8. So here we're going to have 9 minus 6, which is 3, and then 6 plus 8 is 14. So 3/14. I think that sounds about right. Oh, this is an interesting question. So select all of the following tables which could represent a linear function. So for a linear function, I know that as I increment x up by 1, the increment in y has to be consistent, right? So every time I increment x, y ends up getting incremented by a consistent amount. If I think about a parabola, if I increment x, the more I increment x, like the more I increment y as well. So it's not a consistent ratio of increment. So let's see. Let's look at this first table here. So this first table, it looks like the x's are going up by 5s. Let's take a look at what the y values are going up by. So 34 take away 9 is 25. So there's, as I move from here to here, there's a jump of 25. So something tells me this first table is probably not going to be linear, because if I take the 109 and I subtract 34, I get 75. If this was a linear function, I would and because I have like these really nice consistent increments along the x-axis by 5s, I would expect the y to also increment by the same amount, like for example 25 each time or 75 each time. So I don't think this one could represent a linear function. It's incrementing too fast in the y output values. Let's take a look at this table here. Looks like it's going to be a little tricky. This top one, it goes 5, 10, 20, 25. That's not good. Let's take a look at this third one, 0, 5, 10, 15. Again, the x's are being incremented really nicely. So, and it looks like I can kind of see visually that these increments are going to be 10s. Right, do you see that? So from negative 2 to 8 is an increment of 10, and then 8 to 18 is a 10, and then 18 to 28 is also a 10. So this one should be okay. That one should be a linear function, because consistent increments in x give us consistent increments along the y-axis. What about this one? So this one should be relatively straightforward for us to analyze. These are going to be decreases along the y-axis. But is that a 10 again? So I think if I start at 9 and I subtract 10, I get to negative 1. Then if I subtract 10, I get to negative 11, and I subtract 10 again. So it looks like these are all decreasing by 10. Right, so as I move from here to, and that's okay, they don't have to increase all the time, but as long as it's consistent. So these are all decreasing by 10s, so this one should be okay as well. I'm not excited about this last one. Maybe let's look at, so here's an increment of 5, from here to here is also an increment of 5, and then we can take a look at what's happening in the middle afterwards. But let's try to figure out kind of what our baseline looks like. Oh, and this one I can actually see relatively easy visually as well. As I move from here to here, this is a plus 10. And as I move from 39 to 49, I also can see a plus 10. So as I move along the x-axis by 5, I have to move along the y-axis by 10. That's what this is saying. Now what I want to do is I want to take a look at what's happening here and here. Since this is now a plus 10 along the x-axis, I expect the y-axis to be twice as much as what it was for the other two. So this is now a plus 20. So this one should be okay. It looks like every increase of 5 along the x-axis results in an increase of 10 along the
Brace
y-axis.
yourselves, everyone!
So I think we're good here. I think we're good. So question 3, identify the slope in the following question. So 4x plus 2y is equal to 14. We could probably just get this into mx plus b form. So let's move the let's move the 4x over. Let's turn that into a negative 4x. And then we're going to go through and divide each term by 2. So let's divide by 2. So we know that the slope in this particular case should be negative 2. Let the pendulum free fall. Ha 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 ha. All right, question 4. Find the equation in terms of x of the line through the points -1, 5, and 4, 4. So let's find the slope first. So remember, the slope here is given as the difference of the y-coordinates divided by the difference of the x-coordinates. So let's go 4 minus 5, so the difference of the y-coordinates, and then 4 take away -1. It's going to give me -1 over 4 plus 1 is 5. So the slope of our line has to be -1/5. Now, a couple different ways you could finish off this question. I personally like using the point slope formula, so I would probably do something like y minus y naught is equal to mx minus x naught. This is a very handy formula to know, especially when we start looking at calculus stuff. And then we just pick one of these points. It doesn't really matter which one. Let's take the 4 and 4. And so this should be good enough. I believe the computer system would probably permit this to be a final answer. But if you did want to simplify, we could try to simplify this a little bit to get it into mx plus b form. So we could do y is equal to negative x over 5. Well, let's keep it as -1/5 x. I like that. That looks nice. And then we need plus 4/5, and then plus 4. So 4 and 4/5, so 24/5. Right, is that right? So 4 is equal to 20 over 5, right? And we need to add 4 more to it. I think that's okay. So here it is. So I think both of these are probably okay, but just kind of look at the directions that are given to you. So this is what we call point slope form. This is mx plus b form, but they're the same line. So question 5, graph the line through the points -4, +4. Oh, we can do that. -4, +4, that's over here. And then +4, +2, that's here. I don't think my ruler works, but basically we're just going to draw those 2 points and then try to connect them as best as we can with a straight edge. This should be much easier to do, hopefully, on Moodle than it is for me on a screen. So we're looking at something like that. So -4, 4, that seems right. 4, 2, that seems okay.